Welcome back to the channel. So I know in my last video I looked at adding or subtracting algebraic terms. So now we're going to step it up a bit where we're looking at adding and subtracting algebraic fractions. So the main thing for you to remember is how to solve fractions. So the keynote, what are fractions? So these are just unique ways of representing information where we can represent a portion of something. So we always have a numerator and a denominator. So it's the regular way that we solve fractions. The only difference now is that we have variables being introduced. So for a quick recap, we're going to look at how we add regular fractions. So this is our regular fraction over here. So we have a half being added to 2/3. So the first step in anything, there are two main ways you can do it, but for now I'm only going to show one way. So the aim is to find a common denominator, or what we like to call the lowest common denominator, or the lowest common multiple. So in other words, we're being asked to find a larger version of both 2 and 3 where, both of them are factors of that number. So we can always list a few multiples. So multiples of 2 are 2, not 2, multiples of 2 are 4, 6, 8, and it continues. Multiples of 3, that's 6, 9, 12, and it continues. So once you have listed a few, you just identify if there is any number, any multiple at all that is common. In this case, we found that the lowest, or the first one that we're seeing, is 6. So therefore 6 is an appropriate denominator for us to use. So next step, how many times can we get this denominator up here out of our new denominator? So 2 into 6, that's exactly 3 times, which now allows us to use our numerators. Then 3 into 6, that's 2 times, using our numerator again. So that's 3 plus 4. So this gives us a sum of 7 over 6. If you remember, this is an improper fraction as the numerator is larger than that of the denominator. We can rewrite it as a mixed fraction. So 6 into 7 one time, remainder 1 over our original denominator. So that is how we work our regular fractions, and the same applies for how we're going to work our fractions over here, algebraic fractions. So just as we did over here, we find a common denominator. So right here we have 3x and 2x. Yes, they look like terms. However, we need to write a denominator in such a way that there is no change into how it will look in that specific position. So what I'm saying is, if you have 3x here and 2x here, just place them in the denominator so that you limit error and you don't really change the originality of the denominators given to you. So next step, 3x. Look if you can see 3x in the denominator here. Yes, no, yes. So if that's possible, you eliminate it and then you use what is left. So in this case, it's 2x. So we're going to multiply our 2x by our numerator. So it's the same procedure. Same thing over here. 2x. We look if we see 2x, yes. So we eliminate it and then use what is left, which is our 3x. So now we have 2 being multiplied by 2x and our 4 being multiplied by 3x. Do keep in mind that we are not going to expand our denominator. We're going to leave it as is so that we maintain originality. Okay? The only thing that we might expand is the numerator part. Alright, so we can go to the next line. So we can expand this. So 2 times 2x. If you are okay with just writing them out and adding them, that's fine. It would not change your answer. So 2 times 2x, 2 2s 4. And the x is attached, so you write it back just the same. Next one, put back your plus sign, nothing changes, and then 4 by 3x, that's 12x. So you're always going to carry along your x with you. There is no change. So in the end, this would be your final answer. So it's similar to this over here, but as I told you, the only difference is that we're now using variables. So these terms are joined together by operations, and you just have to recall the main steps of how to solve fractions, and it becomes so much easier for you to solve when you get algebraic fractions. So this is one type of how the questions will look on a CSEC paper, and now I'm going to show another example of how they might look. So if you realize, we have the regular numerals in the numerator up here, but for our new question, the regular numerals are in the denominator position. But don't worry, the procedure is still the same. All right, so first step, let me know what I should do in the comments. So we find our common denominator. So in this case, 3 and 4, if we were to list the multiples, that's 12. 12 is a common multiple. 3 into 12, that's 4 times. So therefore, every single thing up here has to be multiplied by 4. Same thing with this one. So if you wanted to do it just like this, that's okay. If you wanted to put the 3 and the 4 down here, that is okay. If you're more comfortable working with it that way, you go ahead and do so. Alright, then 4 into 12, that's 3 times. So everything up here is being multiplied by 3. So we're going to write it in its accurate position. So if you realize anything that we're multiplying over here, it's going back in the same position right here. It's not being switched on all of that. So remember that. 3 is being multiplied by everything over here. Alright, same distributive property again. So the 4 is being multiplied by everything inside. So 4 multiplied by 2a is the same thing as 2a added to 2a added to 2a added to 2a. So that's 8a, and 4 multiplied by negative 1, so that's positive multiplied by negative. It remains negative. Alright, so we found one part. Next part now. So we have minus 3. So we have to use the negative sign here. Why? It's directly attached. We cannot ignore it. It makes sense we just use it as this is an integer and it has a specific value. So it's minus 3, so we're using it down here. So minus 3 is being multiplied by a, and it's being multiplied by positive 2. So negative 3 times positive a, that's negative 3a. Negative 3 times positive 2, that's negative 6. Then we put it back in our same position here. So it's 8a minus 4. Write back this right here. Minus 6, and we put it all over 12. So as you can see here, you can search for your like terms again. So in this case, we have 8a minus 3a, so you have to keep the sign. Negative 4, negative 6. All over 12 again. So our final answer is 5a minus 10 all over 12. So I hope this helped.